Hi everyone, it's Guillaume from Startup Basecamp. Welcome to the Tech for Climate podcast. During the show, you will have the opportunity to meet the best climate tech founders, investors, and experts from both Silicon Valley and around the globe. They will share with you their stories and personal journeys into this growing and exciting industry, giving you some insight into the ecosystems that help you to take part in the fight against climate change and benefit from the opportunities it can represent. The podcast is divided in two small interviews. During the first part, you will get to know our speakers, their perspectives on the climate crisis and how climate tech is changing the game. The second part of the discussion will be for members of our community who will learn the speakers' secret sauce on how to and share with you their unique expertise on topics such as fundraising, management, strategy, and so on, to help you to become a better leader in your field. So before we start, I would like to quickly share what we are doing at Startup Basecamp to support climate tech founders in accessing resources and gaining visibility with investors they seek. Our initiatives include a membership-based community platform offering access to a dedicated Slack group with a growing number of founders, experts, and investors from around the world, and a series of exclusive content such as interviews, weekly job listings, events, and our quarterly online pitch of night opportunity. But more than a place where you can learn, exchange, and grow, we are building a matchmaking service to facilitate connections between our members and top investors and experts in the field. And soon, alongside with other top investors, we will be launching a small fund to co-invest in the growth and acceleration of our members. Finally, all of this is possible because of your support and donations. We are a small self-funded team, and we want you to be part of this collective movement against climate change. So please share one episode with a friend and subscribe to the channels. As an added bonus, we will plant a tree for each of our subscribers each time we reach 1,000 new fans or donors. Do not hesitate to connect with me via social media or email guillaume@startupbasecamp. Thanks a lot for listening. I hope to get in touch with you soon. And now, let's go for the show. Hi everyone, during this new episode of our Founder series, we are sitting down with Noah McQueen, co-founder and head of research at Heirloom. The DAC technology developed by Heirloom enhances a natural process called carbon mineralization to help minerals absorb CO2 from the ambient air in days rather than years. By combining the best of engineering and nature, they can offer the most cost-effective and scalable direct air capture solution in the world. I was very much looking forward to speaking with Noah, whose academic background in chemical engineering provided valuable insight into the direct air capture landscape. Noah has long been an activist and is primarily motivated by advocacy through a social justice lens, beginning with working for several years with LGBTQ+ students in STEM. During their PhD studies, Noah concentrated on DAC technology, but realized the huge gap between the science on an academic level and the need to commercialize these technologies. A realization that coincided with meeting their co-founder and starting Heirloom. In this episode, Noah helps us visualize Heirloom's direct air capture process, what minerals they use, and how they plan to scale their technology to reach 1 billion tons of CO2 capture by 2035. Not only that, but Noah explains the regulatory landscape and how we need to create a sustainable global carbon market so that we grow compliance markets to match voluntary markets. Above all, Noah provides a detailed explanation not only of how to implement direct air capture, but also why it is critical for climate equity and justice. During the second part of the talk, Noah offers a few tips for fundraising, specific for non-software companies, and how they have successfully onboarded big names like Stripe or Wise. Noah also explains how they manage a work-life balance as co-founder and what they read and how to take time off. Noah, welcome to the show.
Hi Noah, welcome to the Tech for Climate podcast. I'm super happy to have you here with us today, and it's a special time for us. It's the episode number 50 that we are recording tonight, so quite special. And so, what a best way to celebrate it by having an exciting companies like yours to the show. And besides that, I believe it's going to be a great opportunity to hear your story and learn more about what you are up to with Heirloom. So, welcome to the show.
Awesome. Thanks for having me. It's great to be here.
So before we start, is the tradition now. Can you give us a 30-second introduction about Heirloom?
Absolutely. So, Heirloom is a direct air capture company that uses earth abundant, naturally occurring minerals to remove CO2 from the atmosphere and store it in a permanent manner.
So let's start from the top. Can you tell us a bit more about your personal story and background? I mean, what are you passionate about? What do you love to do besides building Heirloom? I mean, what makes you feel inspired or like your best self? As I always ask, who is Noah?
Oh, that's a great question. Well, I guess to start, I use they, them, or he, him pronouns, and my background is chemical engineering. I actually chose chemical engineering as I've always been motivated to use my knowledge in a way that would positively impact society, and it felt like a way to apply my love of math and science in a way for an impact that's bigger than just myself. There's a lot of things that inspire me from the pioneering work happening right now in the climate tech industry to the youth and the fact that they're going to take on and have a lot of responsibility for cleaning up the mess that has been made. But I think one of my biggest initial motivations stems from advocacy through a social justice lens. I spent several years working on advocacy specifically for LGBTQ plus students, both in my hometown and in STEM specifically. So combating the climate crisis for me is deeply motivating as it highlights a discrepancy in our society as it disproportionately affects the world's poorest and most vulnerable populations. I guess maybe taking it a little bit outside of work, I really love immersing myself in nature as a reminder of what we're fighting to preserve. I'm very much a frequent hiker, and I generally love spending time outdoors.
So where do you go in the? You're based in the Bay Area, so are you go in the Marine Headlands, or you go a bit further to the Lake Tahoe, maybe, or to the Yosemite?
Yeah, I try to stay local. Twin Peaks is a favorite, but I
Ah,
definitely I love getting a little bit outside the Bay, trying to explore Tahoe and related areas. I just moved to the Bay in January, so I have my fair share of places to go.
so tell us a bit more about your, different work, research, and life experiences prior the launch of Heirloom. I mean, what did you learn along that way? Because I mean, as I was mentioning before the interview, some of the guests has like 10, 15, sometimes 20 years experience, and not that many, are jumping out of college and starting such a, impactful and great company as you guys are doing. So I mean, what did you learn around that journey that you believe in a way gave you an edge to start Heirloom?
Yeah, it's a really great question because I am in an incredibly unique position in a lot of ways. So a lot of my academic experience has actually provided me with the tools to work specifically on direct air capture. My first design project as an undergraduate student in chemical engineering was actually on carbon capture from a power plant. So that was a first exposure to designing these types of systems, what's available. You have MEA as a solvent for post-combustion CO2 capture from these power plants. And then shortly after, I actually had the privilege of taking a course with and then working for Professor Jennifer Wilcox, who is currently on leave from the University of Pennsylvania for the Biden administration. So I worked with Professor Wilcox for about 5 years total, and my projects ranged everywhere from point source capture of CO2 using different minerals and different extraction techniques for those minerals to techno-economic and life cycle analyses for different types of direct air capture processes. So I really was given all of the tools to enter this field in the last like 6 years of my career, and I'm incredibly privileged for that scenario. And Professor Wilcox specifically says that she's creating the human capital to drive the next generation of technologies to combat the climate crisis. And I hope that I'm a good example of that. Um, I, yeah, and throughout my time in research, there was really this emphasis on policy levers needed to enable scaling carbon capture and carbon removal to meet the needs of the climate crisis. So we started to talk about this huge gap between the science and understanding at an academic level and the need to scale and commercialize these systems for, massive gigaton scale carbon removal by mid-century, which is pretty crucial for the climate crisis. So yeah, I guess that's a lot of the experience that set me up to be successful, as well as in the later part of my PhD, I actually was working on a project to develop a low-cost direct air capture process that used earth-abundant minerals to remove CO2 from the atmosphere. And it was around this time I met Shashank, who was on his own personal journey to find, develop, and commercialize a carbon removal technology. So very serendipitous and an incredibly privileged situation.
So would you believe like the encounter with your co-founder was like kind of like the trigger and the motivation to say, okay, now I learned quite a bit. I'm sure you have still a lot to learn in the field, but I'm in the lab. Why not to put that to the world and now like scale it and try to grow that company? Was it that little like flame that you say, okay, now we can join forces and go for it?
Yes, absolutely. And Shashank had co-founded a company, Tempo Automation, in the past, and hearing about the scalability and his belief in this process and my understanding of how low cost the process could get was really kind of came together for, I think, a good meshing and definitely sparked that passion in me to want to actually commercialize this.
So and thank you for covering the part of that initial journey. So in all of this, like, what has been your driver to jump into the climate tech industry? I mean, any specific aha moments that you can recall or you would define as such that really was like, okay, in fact, I'm not taking a traditional road of the scientific road or like maybe going into business or whatever. Like, it's really what I want to do.
Yeah, I think that it actually came to me. I did an internship in biopharmaceuticals, which was what I thought I was going to do, creating life-saving medications and being able to contribute in that way to society. And then when I first stepped into the lab to work with Professor Wilcox during my junior year, I just fell in love with everything that we were doing. I realized that these types of systems, carbon capture from industrial point sources or carbon removal directly from the atmosphere, are absolutely crucial. And then the Intergovernmental Panel on Climate Change, or IPCC, came out with their 2018 report. And the urgency to develop these types of solutions just became more visceral. I mean, I grew up with everything in the background saying that climate change was happening, and I didn't feel like anyone was doing any kind of tangible action to combat it. And that report just kind of solidified it for me. And at this point, I really couldn't see myself doing anything else.
I think it's a good segue for my next questions. Like before we start going into details about Heirloom, I'd like to in the show try to zoom out and understand a little bit like the overall context that your company is evolving on. So let's try to get your overview on the so-called carbon capture landscape today. And I'd like to start with your opinion regarding this larger question, like why is it critical to capture carbon in order to slow down climate change? I mean, maybe we can, start by covering if you have any data on that sense, the global amount of GHG needed to be captured. What are the existing solutions available today? How much is currently deployed in terms of, sequestration capabilities, and who are the main players? And in fine, like who needs it the most, except the whole planet? But maybe there's like other industries that are seeking for, your support.
Yeah. So I guess when it comes to carbon removal, we have this dilemma where we need to do all that we can to stop emitting CO2. And that is easier for some industries than others. So, for example, electricity decarbonization has a solution, but it's much harder to decarbonize other industries, like iron and steel making that makes critical building materials, aviation, which is necessary to kind of connect our global society, and agriculture, which is necessary to kind of feed our growing society. So we call these sectors hard to abate sectors. And while we work to decarbonize as much of the global economy as we can, we also have to offset the continued emissions from these hard to abate sectors. And I think this is where direct air capture really comes in. You can offset those emissions essentially by removing CO2 from the atmosphere directly to reach net zero. There's another need for direct air capture, though, and this comes from, some countries have emitted more CO2 historically than other countries. So direct air capture really comes in and allows those countries to take responsibility for some of their historic CO2 emissions by pulling it back out of the atmosphere. So most of the CO2 in our air today was really emitted by a handful of countries. And those countries, including the US, can take responsibility for those emissions by pulling the CO2 back out of the atmosphere. So that's a little bit about the need for carbon removal and specifically for direct air capture. But when we look at the current landscape of direct air capture, there are really 3 or 4 processes. We've got liquid solvent, solid sorbent, mineralization based, and electrochemical approaches. And each of these systems is fundamentally similar. They capture CO2 from the atmosphere at roughly ambient conditions, so the conditions of outdoors, and they use some kind of capture agent. And then they release the CO2 at some elevated condition, which is typically a higher temperature, a lower pressure, or some kind of a change in electrochemical potential. And that allows the process to capture a purish stream of CO2 that can be stored or utilized. So the landscape itself has been really evolving and transient in the last couple of years, which is really cool as new players come out of the woodwork. We went from having really 3 big players, Climeworks, Carbon Engineering, and Global Thermostat, to having this burgeoning ecosystem of technologies, which is really cool in my opinion. You mentioned statistics. So one interesting statistic that I'll tell you about is that the largest direct air capture plant currently removes about 4,000 tons of CO2 per year. So this is an incredible feat. The largest direct air capture facility deployed to date by Climeworks, but we emit roughly 35 gigatons of CO2 a year. So this means it takes roughly 4 seconds for us to emit the amount of carbon that we currently remove per year using direct air capture. So I think this really emphasizes the need for rapid scaling of these systems coupled to kind of continued innovation.
And if you like assess in terms of the amount of gigaton of greenhouse gases needed to be removed to in a way counterbalance the climate change effect. I mean, you mentioned 35 gigaton. Is that what we emit on a yearly basis, taking into account a projection of this slow decarbonization of the economy? I mean, what would be, according to you, the amount or the capabilities that we should have in place to kind of at least mitigate what we have, and I guess in the future keep pumping carbon or GHG out of the atmosphere to kind of compensate all the mess, if I can use that word, that has been done for the last century?
Yeah, and that's a really, really interesting question that's actually highly debated. Typically, numbers range from anywhere from 1 billion tons to 20 billion tons of carbon removal from the atmosphere. And that's required to get us to net zero by 2050, and then, further to offset some of those historic emissions. It really does depend on how fast and how robustly we can decarbonize the economy, though.
So I think this is a good segue for my next question. I mean, what are the challenges and opportunities that you see in the market to accelerate, GHG sequestration capabilities deployment? I mean, what is blocking or slowing it down right now? Is it because of a need for new regulation to really push, the market up and in a way decrease the green premium? And I don't even know if green premium is applicable for this kind of technology, or maybe the technology, as you mentioned, like Climeworks is doing 5,000 tons a year, which is way too like a little drop of water in the ocean, if I can use that image. So maybe it's the lack of capital to fund those projects, or it's because economically speaking it's not viable and the cost per ton is still way too expensive compared to the carbon market price, I would say.
Yeah, I think you touched on quite a few things there, and I'll highlight a couple of them. But the first one with respect to regulation is that how do we create and sustain a global carbon market is a huge, huge question. And currently, the landscape for carbon removals is dominated by a handful of voluntary carbon credit procurement companies, or companies procuring carbon credits. So those are the Stripes, the Shopifys, the Microsofts. And this investment is crucial and valuable to pushing direct air capture down the cost curve. But at some point, it will be important for compliance markets to meet those voluntary markets. And that's really where you get this rapid scaling that can push the technology to gigaton scale carbon removal. In addition to kind of regulation and creating robust markets for carbon removal credits, we also need investments in infrastructure for direct air capture. So an example of this is the Department of Energy in the US has their direct air capture hubs initiative, which is a huge investment in helping scale direct air capture. This is the geologic storage, and that includes permitting, accessibility, monitoring, verification, which is crucial for the CO2 produced from direct air capture. This includes continuously available clean renewable energy, which is crucial for the life cycle of direct air capture to net remove CO2 from the atmosphere. It includes access to utilities, and setting up that infrastructure and enabling direct air capture technologies to plug in is very helpful, because it's all of the contingencies and the other systems that direct air capture needs to be successful that we really need infrastructure invested in. And then additionally, financing for deployments. Direct air capture, it does require significant capital investment. So grants or low interest or free loans from the government to finance deployments is kind of another critical policy lever that can be pursued to help push direct air capture to scale. Maybe pushing on the green premium. Maybe in the long run, governments also procure carbon removal credits to help offset current and historic emissions, but that may be later down the line than what we need right now to help push carbon removal to scale.
So do you see any difference between the US/North America and the EU in itself in terms of like maybe, amount of project or like policy in place, or like, I would say like the overall like direct air capture landscape? Where do you see that right now this the most excitement and progress as well in terms of like capturing CO2? Because not about just like buzzing and I know that the press love to speak about this kind of like the silver bullet that will save all of us, but so how do you see, like, do you see any difference in on, or maybe you don't have a view on the European side, I don't know, tell me.
Yeah, I would say I have a different view, but I think that we can't view direct air capture as a silver bullet. That's for sure. We need a portfolio of technologies and as many tools in our tool belt as we can have to combat the climate crisis. So that's one thing I really want to highlight. But I guess with respect to direct air capture, I have seen a lot of companies coming out of the woodworks in the United States. I know the US has a couple of different incentives, including tax credit 45Q, which it really isn't of the right scale. It caps, or the minimum threshold is about 100,000 tons of removal, which is, as I mentioned, much, much higher than current capacities for direct air capture. So that's a potential market. But then on top of that, you have California's low carbon fuel standard. And that enables direct air capture to kind of plug into that market when it's available. So those are the two US-based incentives. And then I know that the EU has the emissions trading scheme, which is actually starting to facilitate more industrial decarbonization. And I'm not yet sure how exactly that translates to direct air capture. So I do see burgeoning carbon capture, carbon removal ecosystems in both countries, with a bit more focus on direct air capture in the United States.
So to close this section, I'd like to get a little bit your opinion on and you already touched up on, excuse me about that one, on the carbon market, and you mentioned the voluntary carbon market, and hopefully we'll move towards like something more regulated and enforced in a way. But what is your opinion regarding this, risk of like greenwashing, like, big emitters trying to use, carbon capture or like carbon credits, by, natural process like replanting and stuff like that. And just to, in a way, slow down the process of decarbonizing their infrastructure and their assets. Do you really see like is there a risk there, or is it really something that necessarily should be anyway put in place to accelerate the change, and we have no other way to do it right now?
Yeah, I think greenwashing is a huge risk. Going back to the tax credit 45Q that I mentioned, most of that credit has gone to oil and gas companies that are doing a process called enhanced oil recovery, where they actually inject CO2 underground to recover more oil from the earth that would otherwise be unrecoverable. So in that process, they're able to claim this tax credit 45Q, but they're producing more oil, and the life cycle or net CO2 emissions of that is very iffy. So I think that greenwashing is a big concern for me. And that actually comes back to how do we certify quality of some of these offsets and removal credits. And I guess if I'm able to go on a bit of a tangent, I think there's a lot of aspects of high quality removal that we can play into a certification system. So the first one is that it's additional, meaning that the intervention actually causes climate benefit. So this is above and beyond what have happened otherwise. Similar, if you have a forest on your land, you can't suddenly claim offsets for that forest. But if you plant a series of trees on your land, you could claim offsets for those trees that were planted in addition to the forest that existed. It has to be scalable, meaning that you can get to gigaton scale or orders approaching gigaton scale without barriers. has to be durable, meaning that the CO2 is removed from the atmosphere in a safe and stable manner. Has to be monitorable and verifiable, meaning that you can measure the exact quantity removed and the duration that the CO2 is kept away from the atmosphere. And most importantly, to a lot of these systems, it needs to be net negative, meaning that after all of the CO2 emissions from the process are accounted for, more CO2 is removed by the process than was emitted from the system. So if we start to develop frameworks around understanding the quality of removal, or whether these offsets and credits are durable, whether they're net negative, we can really start to put together a picture of what is greenwashing and what is the viable carbon removal technology with positive climate benefit.
So, and thanks for sharing that. So according to you, like the best way to fight greenwashing, at least on the larger corporate level, would be putting together this regulation and framework and ensuring the quality of the offset. Do you see any other ways where we could fight maybe this greenwashing, or at least not be not be a sheep and just listen to them and buy their green website that they all propose to us right now, or green product?
Yeah, I mean, I part of it is doing your own personal research too. So before buying a product or a greenwashed product, I guess, being able to see what's going into that, where are they actually offsetting this from, how is it deemed more green than the alternative? And I think that amount of diligence allows the individual to see, okay, well, how much thought and intention was put into this, as opposed to how much is this more of a marketing ploy to get people who are more environmentally conscious to purchase these products.
Mm-hmm. Okay, thank you so much for sharing this all context and sharing all of your very valuable insights. So let's go deeper into Heirloom. I mean, you already uncovered a bit the story, but if you can tell us a little bit more about the genesis of it with your co-founder in itself, which is the gap that you identify at first and that led to the current version of it, and in a way, why did Heirloom had to exist? And after that, we'll go into on the product side to understand really the product in itself, or how it works.
Yeah, absolutely. So we talked a bit about this high quality carbon removal, which was actually a really good segue. The initial gap that was identified is that we need a low cost, high quality carbon removal approach to, and specifically the way in which we identified that was that direct air capture fits a lot of these buckets. It's additional, it's scalable, it's durable. You can monitor and verify the CO2 injected, and it's net negative, project specific. But it's not a low-cost system. So primarily, this is on account of really high energy requirements associated with direct air capture and custom expensive materials that capture CO2 from the air. So the initial gap that we identified was, we've got this direct air capture process that could be really impactful for climate, but it's much too expensive. And what was noted, and the initial idea was from Peter Kellman at Columbia University, is that what if we take these inexpensive minerals and we just lay them out? We lay them out passively exposed to the atmosphere, and we get rid of all these expensive capture chemicals and the front end energy with fans to push air through these complex geometries in order to facilitate air to material contact. And we just said, we're going to leave it there until it uptakes CO2 sufficiently. We'll recollect it and we'll regenerate those minerals. And this was really a merging of direct air capture and carbon mineralization. So we could use low cost capture materials in order to do direct air capture. And this would enable us to achieve a low cost, high quality carbon removal system that fits that market need that we weren't seeing at the time.
So I think it's definitely, we want to know more about the product and how things work. So if you could walk us through the process for non-scientists, as I mentioned, to make sure that the large audience of investors and founders that are not technical and not scientists can understand. So how does it work? I mean, which type of minerals that you guys are using? Where are they available? How do you extract them? I have a ton of questions here. I mean, do they need specific transformation after that? I mean, what is the ratio that you need to compare to, capturing a ton of CO2? And I've, if you can help us to visualize a bit the process and walk us through, we want to understand your secret sauce.
Yeah, absolutely. And I will say the foundation is keep it simple. So our process, as I mentioned, uses naturally occurring earth abundant minerals, which is calcium carbonate or limestone. And this material, we send it into an electric high temperature reactor. So inside this reactor, calcium carbonate releases a CO2 that's kind of caught up in its structure, and that produces a pure stream of CO2. We can capture that and sequester it underground. And then we result a calcium oxide, or CaO. And that oxide is super thirsty for CO2 at atmospheric conditions. It had a CO2 when it was stable. Now it's released that CO2 and it's unstable without a bound CO2. So this calcium oxide can be laid out on trays, and those trays put into racks. And you can think of these like giant baker's racks that are just outside exposed to air. And when we lay out this material, it naturally uptakes CO2 from the atmosphere and forms calcium carbonate. So that's our starting material. We like that. And while this process typically takes months to years to complete at ambient conditions, we've actually accelerated this to less than a week. So calcium oxide to calcium carbonate in less than a week. And after that carbonate is reformed, it can be fed back into that high temperature reactor, where it once again releases its CO2 and forms calcium oxide, capture that CO2 this time from the atmosphere, and use that calcium oxide to capture more CO2 from the air. So it's a cyclic process going between calcium carbonate and calcium oxide.
Okay, so how does it work with the use of this reactor? Like how big, how large does it need to be? And then I guess on the side of the reactor you have all of those trays. Probably you put them with like accelerate the process, as you mentioned, with like some fan pushing the air through all of those like piece of stone that are not like probably like perfectly squared or shaped. And my question is like, how much mineral do you need to capture a ton of CO2? How efficient is that? You know?
Yeah, those are all great questions. So I guess starting with the reactor, we aim to create modular reactors. So you're talking thousands to tens of thousands tons of CO2 a year in a single module. So they're not too incredibly massive, and they are scaled to meet the throughput of the carbonation system. And to be most efficient from an energetic perspective. When it comes to how we actually accelerate the carbonation, that is indeed our secret sauce. So we don't use fans, we don't use any kind of engineered system to move air through our contactors, but we do maintain favorable microclimate for the minerals, and that enables them to uptake CO2 much faster than they would just regularly exposed to air. Yeah, and then I apologize, but I lost the last question that you asked.
No, and my last question regarding that was like, what is the ratio in terms of minerals to capture like a ton of CO2? Is it like, do you need like a ton of minerals for a ton of CO2, or is it like what's the ratio, and how fast can you go to that billion ton that you guys want to capture by 2035?
Yeah, it's a really great question. So per cycle, it takes about 1.4 tons of minerals to capture a ton of CO2. But if that material is used for hundreds of cycles, then you're capturing hundreds of tons of CO2 per ton of mineral over its lifetime. So it really depends on what frame of reference you take. With respect to scaling to 1 billion tons, we see ourselves, our next step is de-risking the integrated system, and then moving to a first demonstration plant at hundreds to thousands tons of CO2, and moving to a full commercial plant following that. So we think if we can keep this pathway of scaling quickly and doubling 10x in capacity, we can reach the 1 billion ton target by 2035.
Okay, and a couple of more questions on the technical aspect. I think it's really fascinating. So in terms of the what is the end product that you guys, I mean, it's obviously the CO2, but in which form is it? Like are you turning it into a liquid form, or are you like it's still gas, and how do you store it like permanently? You mentioned that you guys are collaborating with like partners, so how does it work? Like, is it on site, or is it like in different location? Tell us a bit more about that.
Yeah, so there are actually two product streams from our process. The first one is the CO2, which is in supercritical conditions. So that means that it's ready for pipeline or truck transportation. The conditions we'll deliver it depends on what type of transportation we would need, or whether we're co-located to an injection partner. So one of the really neat things about direct air capture is that it's not truly locationally constrained, but it is favorable to put it next to a geologic storage facility. So you could site a direct air capture plant next to the injection well where you want to store your CO2. And there are several different options for storing CO2. So you can store it in suitable geologic reservoirs, which oftentimes this is actually where we've pulled oil and gas out of the ground, and now you have a depleted oil and gas reservoir. So it can be repurposed for storing CO2, and a lot of the infrastructure is available. And in some cases, these wells have already stored CO2 because of the enhanced oil recovery that oil and gas companies have been doing in these types of locations. So that's one way. You can also store it via mineralization. So this is mixing CO2 with a water stream and injecting it into a suitable geologic reservoir. And this is typically basalt rocks, magnesium hydroxide. And in this process, over the course of a couple years, the CO2 actually mineralizes with the minerals in the subsurface, and that permanently stores the CO2 away from the air. And then the final form, sorry.
No, I was just mentioning like a company like CarbFix does that.
Yeah.
But please go ahead. It was very interesting what you were saying.
Yeah, we actually partnered with CarbFix for the Carbon Removal X Prize too. So their process, it makes us mineralization squared. It's kind of fun. And then the final way that we think about maybe permanent storage in a way that actually creates a value-added product is curing concrete. So you can mineralize CO2 in concrete during a curing step. It forms carbonates, and that is then used in building materials. So that's a third pathway that we see. So that's what we do with the CO2. And then the other waste stream I was referring to is the calcium carbonate once we've finished with it in our cycle. And it's easily end of lifed, or we can actually upcycle this into concrete, as limestone is one of the biggest feedstocks for cement and concrete production. So we really have two different products there.
Okay. So last question on the technical aspect, I promise, but I kind of want to understand in terms of like energy consumption, like what is the ratio there? Because you have this reactor, you guys are like, probably needs quite a bit of like intense heat, or I mean, so what is the entrance and what's the ratio at the end, like in terms of CO2 capture versus, I guess you probably will in the future, or you're already doing it now using, renewable energy source. So how is it going on that sense? Like, how do you see the facility in terms of like net zero facility finally, I would say.
No, it's a really crucial question for not just Heirloom, but direct air capture more broadly. But we have electrified the reaction step. So we use renewable electricity. That's something that we very intentional on from the beginning to avoid the use of fossil energy and fully electrify our process using renewable electricity. It really, really helps the life cycle analysis of the process. So when we talk about energy requirements per ton of CO2, our target is 1,500 kilowatt hours per ton of CO2 captured. And that really is low end of industry. So we have optimistic, some of the most optimistic projections of direct air capture that we've seen so far. So it really does come from fundamental improvements in the process and eliminating some of that energy in the front to essentially allow us to achieve those really low energy requirements.
Okay, so how long did it take you guys and your team to put together the first prototype? I mean, what were the initial challenges and how did you overcome them? I mean, at which stage are you guys now in terms of like prototyping? I mean, is it like a pilot? Is it like, do you see already like the next larger facilities around the corner? I mean, what keeps you up at night, I would say?
Yeah, it's a great question. I think that when it comes to challenges, that the big and meaty engineering challenges that we've come across so far, the first one is modularity. So we've designed our system to hopefully emulate the learning rates of solar and wind. And what I mean by that is creating a system that can be repeatedly manufactured so that we can actually drive down the costs of direct air capture on this cost curve. So modularity can refer to a lot of things, but in that case, it's the system being partitioned into smaller and smaller units that enable us to iterate very quickly. So designing for modularity and designing modularity into what is traditionally thought of as these massive systems to remove CO2 from the atmosphere, is one of the key challenges that we've run into and been able to overcome to an extent in our current development. And we have several different prototype carbonation systems that are uptaking CO2 from the atmosphere. In addition to the modularity, another key technical challenge is maintaining the high CO2 uptake rates in our materials. So we give our minerals superpowers that enable them to take up CO2 much faster, and that requires significant integration of geochemistry and carbonation with equipment design and industrial automation. And these components, bringing them together has really been challenging, and one thing that we've been able to overcome so far in our development. With the scale that we're currently operating at, we currently have several operational prototypes and are working towards our first commercial demonstration scale plant in early next year. So I would say we see that next milestone in the line of sight. And once we've done that, we're working towards our first commercial deployment of a scaled module system, ideally.
Thank you. So what are the current and expected economics of Heirlooms? I mean, how much does it cost to deploy one of those units, and what is the expected cost, I would say, in the future when, thanks to this, smart design and modularity and being able to produce at scale, I guess it will drastically. If you have any figures that you could share with us, I mean. And last question is, like, I saw that in terms of the economics part of it, you already have some clients like big brands like Stripe or Wise committing. So are they paid customers that are already like also supporting the company? Tell us a bit more about all of that.
Yeah, so we do have some customers that are already supporting us, and the cost of some of our initial tonnage is obviously much more expensive than where we expect to be in the future, since we are on this kind of pilot scale. So we sold our tonnage to Stripe at about $2,000 per ton. And we do expect that to be an outlier. Our next plant will be significantly cheaper. And we want to demonstrate that we're able to come down the cost curve very quickly, with our cost floor being comfortably below $100 per ton, approaching that $50 per ton mark that we really think will be revolutionary to the direct air capture industry and allow us to be competitive with even point source CO2 capture.
Okay, that's exciting, because below 100 USD, it's challenging, and if you guys are able to reach that point, probably the carbon credit market will also meet the demand, and then it will be like a big success. So, can you tell us a bit more about like your competition today, and you already uncovered that a little bit by covering the landscape, but how do you see your company? I mean, how different are you, or maybe better? How do you compare yourself and to the other solution available on the market?
No, it's a really great question, and there are more direct air capture companies now than I think I know the names of. So it really is a burgeoning industry. But I think that Heirloom does three important things that kind of sets our technology apart from other direct air capture approaches and gives us that potential to achieve costs less than $100 per ton in a really scalable way. So the first one is, as I mentioned, we use these low-cost, earth-abundant minerals to capture CO2, which is very different from approaches that use highly engineered specialty materials. In fact, we don't use these. Instead, our two biggest material contributions are steel and calcium carbonate, which happen to be two of the largest global commodities today. So we see that there's this incredible opportunity to innovate within existing supply chains that may not exist for other direct air capture companies. We can also, on this note, talk about the benefits of using mineral materials, which include that they're cheaper than highly engineered materials, they're safer for human operators, they can be easily disposed of. As I mentioned, they can even be upcycled into cement or concrete production and make them essentially free to the process. And they require significantly less energy to produce. So all that goes into helping process economics as well as scalability. Mm-hmm. The second aspect of the process that allows us, or is novel to Heirloom's process, is that we perform the capture process, allowing the mineral to naturally take up CO2. So this doesn't require any kind of forced airflow and minimizes the energy requirements associated with actually capturing the CO2. So while existing companies rely on that forced airflow, it can be capitally intensive and also add to their overall energy footprint. And then finally, as I talked about in our challenges, which is also a strength of the company, we're designing a modular approach that allows us to quickly iterate and repeatedly manufacture the same infrastructure. So this means we can really leverage mass manufacturing and the technology learning that comes along with repeated manufacturing and iteration to achieve that below $100, closer to $50 per ton cost.
Mm-hmm. So last question on my side to not take too much of your time for this part one, but what is, according to you guys, like the market opportunity? I mean, you mentioned the maybe 1 billion ton a year, maybe like 35 billion ton. I mean, it's still a bit fuzzy, but I mean, and how are you planning now to scale your operation? I mean, what are the steps to achieve it? What needs to happen? I mean, and what's next in a way for Heirloom?
Yeah, also a great question. I think that maybe talking about market size, probably somewhere between 1 and 10 billion tons of CO2 per year is a good approximation. I think that there are some variations on both the high and low end of that, but 1 to 10 billion tons seems like a realistic estimation of how much carbon removal we will need by mid-century in order to really combat the climate crisis. With respect to Heirloom's kind of roadmap, where we're going, currently we're heads down building our first kind of pilot plant and then our first commercial demonstration facility. So we're currently really focused on integrating the technology, showing that it works, and de-risking our process at all steps to make sure that, when we go for that first commercial scale deployment, we were completely ready. So that involves currently looking for skilled engineers and scientists to help us, as well as beginning to build out that equipment in-house.
And what would be the timeline for you guys? Like, are we talking about like 6, 12 months, 24 months for this being able to move to the next step, which is the commercial facilities that you could put in place?
Yeah, so our first demonstration commercial facility is somewhere between that 6 to 12 months range, and that'll be hopefully early next year. And then our scaled commercial facility should be 2024 timescale. Okay.
So what is your personal opinion on the climate crisis? I mean, what would be your words to the people who are afraid of all the terrible, news and already visible consequences like wildfire, flood, drought of climate change? Are we doomed, as I always ask? What would you tell them?
Yeah, one of our values at Heirloom is actually persistent optimism. And I think this really resonates with me because it's the understanding that climate crisis is a daunting problem that one individual alone will not solve and a global community cannot solve overnight. So instead, we kind of have to gradually and consistently chip away at the problem and continue to make that progress towards a solution. I don't think it'll be easy, but I am persistently optimistic that if we continue to work quickly, we can affect global and even systemic change that we need to combat climate change. So I personally don't think we're doomed. I don't think that doomism serves anyone positively, but I do urge those people that if you do feel doomed or stuck, find a way to apply yourself or your skills to be a part of that solution, whether it's, repurposing free time to work on climate, or whether it's like shifting and finding a way for your technical skill set or your business acumen to be utilized for climate change. Like there really is a place for everyone in this field, and we really will need a massive shift in the workforce even to make this a reality.
So how can the community of listeners, founders, investors, experts can help you today?
I feel like that was the perfect setup. We are hiring. If you know any interested, if you or yourself or anyone who's interested in talented engineers and scientists, don't hesitate to reach out. We're hello@heirloomcarbon.com, or you can visit our website at www.heirloomcarbon.com. Always interested in those conversations and talking to people who are truly motivated by combating the climate crisis.
Any question that I did not ask you that I should have for this first part of the interview?
Not that I can think of. That was pretty covered it all, yeah.
Fantastic. Thank you so much, Noah, for your time, your incredible insights in the industry, this amazing work that you are doing for everybody on Earth, I would say. So I'm so excited to see so many brilliant people like you putting so much effort to move the ball towards a better and cleaner world. So thank you so much for coming with us tonight.
Yeah, thanks again for having me. That's great.
Hi, it's Guillaume again. Thanks for listening. I hope you enjoyed the show. As I said, do not hesitate to share an episode with a friend. Also, if you value the work we do for the climate tech ecosystem, here is how you can contribute to it. Today, I'm asking for your support and a donation or sponsorship to make the work of our self-funded team more viable. Even a small contribution means a lot to us. In any case, I will invite you to subscribe to our channels and visit our website startupbasecamp.org to discover more episodes like this one. And get your membership to access all our members' exclusive content. So remember, all of this is possible because of your support and donation. And we want you to be part of this collective movement against climate change. Let's keep in touch, and I hope you will enjoy our next show with us.